I want to say whether the function graphed is continuous on -1, 3. If not, where does it fail to be continuous and why? Let's first start off with my first function. So we're looking at the closed interval from -1 to 3. Okay. So notice there is a hole at x equals 2 over here. And f of x is not defined at x equals 2. So we say that the graph is not continuous at x equals 2. Okay, let's look at another example. Let's say we have a similar graph. Now at 3, there's a hole and there's a point there above the hole. So if we consider the limit as x approaches 3 of f of x, well, that limit, so just to be precise, we have to go from the left here, right? Because there's nothing defined to the right of my function. So that's why we have to only look at it from the left side. And the limit here is going to be 1. But f of 3 is equal to 2. So since the limit as x approaches 3 from the left of f of x does not equal f of 3, then it's not continuous. So it's not continuous in that interval. Okay, so let's look at a more exciting graph. Let's say we have two lines like this. Let's try this again. So we want to line up these lines, these 2 points, on the same x value. So that x value should be at 1. So x equals 1, and this will be at -1. We'll say this is 1, and 2, and this is 3. So notice the limit as x approaches 1 from the left of f of x, and the limit as x approaches 1 from the right. Well, from the left, we're coming up this function, which is at 1 for the y value, and from the right, we're coming down here, and we're approaching 1. We're approaching 0 for the y value. So the limit here doesn't exist, and which is not equal to f of 1, where f of 1 is equal to 0. So it can't be continuous at x equals 1. And if we look at x equals 3, at x equals 3, there's a hole there. It's not defined at x equals 3. So the 2 points where the function is not continuous is at x equals 1 and x equals 3. Now let's look at a function, so a piecewise function. We have x squared minus 1 if x is between -1 and 0, and 2x if x is between 0 and 1. 1 if x is equal to 1. Negative 2x plus 4 if x is between 1 and 2. And 0 if x is between 2 and 3. Okay, so if you graph this, so we have what looks like a semicircle on the left here with a hole at 0. And then there's another hole at 0 here. And we're going to have a triangle. And the peak of the triangle is at x equals 1. And that's going to be a hole, actually. And the y value here is 2. There's a point x equals 1, y equals 1. And then between 2 and 3, that's a hole, and it's going to be 0. Okay. So this isn't the best graph, but let's see. This is 1. This is 1 as well. Now let's answer some questions. Does f of negative 1 exist? Well, we go where x equals negative 1, and it's this point right here. Notice I don't have it as a circle. There's no hole there. So clearly it's defined, because f of negative 1 is equal to 0. So it exists. Does a limit as x approach negative 1 from the right exist? Well, if we're coming from the right, we're coming along this quarter circle, and yes, it approaches 0. So the limit as x approaches negative 1 from the right is 0. The next question, does the limit as x approach negative 1 from the right of f of x equal f of negative 1? Well, from above, this we said is 0. And then f of negative 1 is also 0 from here. So yes, those two are the same. And finally, is f continuous at x equals negative 1? The answer is yes, because the limit is equal to the value at x equals negative 1. So by definition, it's continuous at a point if it's the same value in that point. Okay. Next, let's look at f of 1. So does f of 1 exist? The answer is yes. F of 1 is 1. That's this point right here. Does the limit of x approach 1 of f of x exist? So let's take a look. Here we have to consider the left-hand limit and the right-hand limit. So from the left-hand limit, we're coming up along this line right here, and it's going to approach 2. And if we're coming from the right, we're also going to approach 2. So the left-hand limit is equal to the right-hand limit. So yeah, so the limit as x approaches 1 has to be 2. So it does exist. And does the limit of as x approaches 1 of f of x equal f of 1? So let's take a look at this. Well, we said the limit is 2, f of 1 is 1. So no, those do not equal each other. Now, is f continuous at x equals 1? Since we have this since they're not equal to each other, we cannot say they're continuous. So f is not continuous at x equals 1. If instead we said this was equal, then yes, it would be continuous. Okay. Now, is f defined at x equals 2? Well, at x equals 2, there's only a hole over here. So no, f is not defined at x equals 2. And we can look at the bounds to be precise. See, here it's strictly less than. So 2 is not being involved in this piecewise function. So no, it's not defined. Is f continuous at x equals 2? No, because it's not defined. If it was defined and the left-hand limit equals the right-hand limit, so actually in this case, the left-hand limit at 2 and the right-hand limit are equal. So the limit exists, but it's not equal to f of 2. So we cannot say it's continuous.